Most of us have a short-term view of the world we live in and are thinking about trivial things, like hoping for an end to a long cold winter, the next school year, or maybe even retirement. But these things are just a blink of an eye in cosmic terms. So let's think really big and look forward millions and trillions of years from now into the future. Every species that has ever lived on Earth is now extinct. And like all life on the planet Earth, our time will eventually come either from natural and man-made disasters, an asteroid strike, a worldwide pandemic, or global warming. Even a nearby supernova explosion could send the whole planet into a mass extinction event. But what if we stopped going backward and instead advanced to a point that we could harness the energy of a black hole and even live inside one? Keep watching to find out. If you're thinking about how long we have, someone has already thought of it. There is a calculation called the Doomsday Argument, which was developed in 1983 by an astrophysicist named Brandon Carter. According to his calculations, if you assume that half of the humans who will ever live have already been born, you'll get about 60 billion people. If you also assume that another 60 billion are yet to be born, our population levels only give us about another 9,000 years or so. That means there is a 95% chance that humanity will end by the year 11,000. In terms of how long the Earth will be around, it's a drop in the bucket. Even if we do evolve and become more intelligent as a species, in about 500 million years the temperature of the planet will rise to the point that the Earth will transform into a desert world. Evolution will move in reverse, and the largest and least heat-tolerant creatures will go extinct, leaving hardy insects and even tougher bacteria, and only organisms that have already lived deep underground for billions of years will survive. The oceans will slowly boil away, and there will be no place to hide from the terrible temperatures. This is because the sun is very slowly expanding and will become hotter and brighter. 5 billion years from now, the sun will begin its final stage of life, using the last of its hydrogen fuel supply. And gravity will force the sun to collapse, with only a small amount of hydrogen remaining as a shell wrapped around the star's core. Some scientists say that the sun will expand, causing the Earth to spiral out away from the sun, in which life could survive. But in another scenario, the sun's outer envelope will enclose the Earth, and the additional friction will slow the planet down, causing it to spiral down into the sun, which will be a fiery and cataclysmic end. Eventually the sun will fade out to form a planetary nebula and become a white dwarf until it cools down and its light fades forever. We know this is happening now because the universe acts as a natural time machine. When we look out into space, we see distant objects not as they are, but as they looked like in the past. The mysterious dark energy force, an unknown form of energy which is hypothesized to permeate all of space, is accelerating the expansion of the universe, making the most distant galaxies move away faster and faster from us. Once past the event horizon, any light emitted from these distant and ancient galaxies will fade from view, and they will disappear forever. To put that in some perspective, if there are future astronomers living 3 trillion years from now, they will only see our own galaxy when looking into the night sky. Even the cosmic microwave background radiation will have faded away, as well as leaving no trace of the Big Bang. If you want to see what will happen to our own Milky Way galaxy one day, then just look out into space in all directions, and you'll see galaxies colliding, tearing at each other, and stripping off gas and dust materials, and generating huge swaths of star formations. The Andromeda Galaxy will collide with us in 2 billion years from now. The two galaxies will collide, then pull apart over and over until they form a new, larger galaxy. Some are calling this future galaxy Milkomedia. The collision will leave behind twin, supermassive black holes that will orbit one another until they eventually merge together, forming an even more massive black hole. And despite this galaxy merger, it is quite possible that the Earth and life could survive. But this process doesn't continue on forever. If we look out into deep space, we can already see older elliptical galaxies, which have already used up their free gas and dust, and instead of seeing bright and hot stars, we see aging red stars and white dwarfs that are cooling down. One day there will not be any newly forming stars, and the red dwarfs and the dimmest stars will turn into black dwarfs. The entire universe will go black, as if someone turned off the lights. If humans have survived, they will learn to adapt to the darkness and harness the last source of energy left, black holes. Some researchers say that these collapsed islands of space-time are the universe's ultimate energy source and are far more efficient at converting mass into energy than the fusion engines of stars. As a species, we have all contemplated the existence of extraterrestrial civilizations living in the farthest reaches of the universe with some kind of mind-boggling technology. So far, we haven't seen any signs of anything beyond Homo sapiens, which is quite depressing and equally terrifying. After all, if there were aliens, there would be some sign of their existence, right? The Fermi paradox gives some theories of why there may be no signs. From our technology being too basic compared to other advanced civilizations, and so we have no idea what to look for, to advanced civilizations knowing that we are here, but choosing not to contact us in an effort to avoid hindering our natural progress. Now there is a new theory that makes these alternatives look lame in comparison. Astronomers have recently made a colossal discovery using NASA's Chandra X-ray telescope and found a series of ultra-massive black holes at the center of many distant galaxies. Each one of them is more than 10 times the size of our solar system, with event horizons stretching out more than 5 times beyond the orbit of Pluto. They are larger than anything ever found and could be home to the oldest civilizations because of the ancient stellar population. One of these is at the center of an egg-shaped galaxy more than 335 million light-years away, called NGC 4889, and it has a mass of more than 21 billion suns combined. And there is another behemoth at the center of NGC 3842, which is 331 million light-years away and contains the mass of 9.7 billion suns. Compare that with our own Sagittarius A at the heart of the Milky Way, with only a mass of 4.1 million solar masses, and you get the idea. So why is size important? It's been found that the surface of a black hole becomes less extreme the larger it is. Hypothetically, if we were able to find and reach a supermassive singularity the size of our solar system, it might be possible for there to be a stable area within the event horizon which could, theoretically, allow stars or planets to orbit the central singularity without being swallowed and torn into subatomic particles. A Russian cosmologist by the name of Vyacheslav Dukachayev theorizes that there could be ancient aliens who are currently living on the edge of spinning and charged singularities that are massive enough for weakening the tidal forces and radiation of gravitational waves to an acceptable level. These have a special name and are called Reisner-Nordstrom black holes. So what kind of technology is required for this? The Kardashev scale was developed by Soviet astronomer Nikolai Kardashev in 1964 and is a method of measuring a civilization's level of technological advancement based on the amount of energy a civilization is able to use. A Type 1 civilization, which is also called a planetary civilization, can use and store all of the energy available on its planet. Sadly, humans have yet to reach this point. A Type 2 civilization is called a stellar civilization. It can harness the total energy of its planet's parent star with the popular hypothetical concept of the Dyson sphere, which is a device that is built around the entire star to transfer its energy to the planet, such as a network of solar power satellites that would enclose a star completely and capture most or all of its energy output. Finally, there is a Type 3 civilization called the Galactic Civilization, which can control energy on the scale of its entire host galaxy, such as the ones that could be living on the edge of an ultra-massive black hole. It is possible that these advanced extraterrestrials could derive light and heat from the orbiting photons and energy from within the singularity itself. The most interesting thing about this theory is that such civilizations would be completely closed off to the rest of the universe beyond the event horizon. The same as we cannot see anything inside of it. It sounds like a really nice place to hide, albeit a very lonely one. But this could explain why we have not heard from any aliens yet. They are simply hiding right before our very eyes inside of ultramassive black holes, having lost their parent stars as an energy source. A super civilization may even attempt to artificially create a universe in the laboratory by black hole fabrication. The mind-blowing thing about this idea is that it might explain why the many constants in our universe are so precisely tuned for our existence. But even black holes won't be around forever, and were once thought to be like one-way streets, where matter goes in but never comes out. It was the late great astrophysicist Stephen Hawking who came up with the theory in 1974 that black holes evaporate by releasing a tiny amount of energy into space. This is known as Hawking radiation. When the last black hole evaporates, all that will remain in the universe are photons of radiation and elementary particles that escaped capture by the black holes. The temperature of the entire universe will reach a final temperature just above absolute zero. The hypothetical dark energy is a mystifying and unknown force that may play some future role, continuing the expansion of the universe, accelerating each of these elementary particles and photons away from each other until they're effectively cut off from one another. And this time, there will be no gravity to bring them together again. And in the cold darkness, perhaps there will be another Big Bang, that the universe is cyclical and the whole process will start up again. But then again, perhaps it won't, and the bleak future of a cold and dead universe is all that awaits us. It might not sound like a happy ending, and it won't happen for trillions of years, but it's awe-inspiring to consider the long future ahead. It helps us appreciate the age we live in today. We hope you enjoyed this video. Let us know what you think in the comments. And if you like the video, then click subscribe and turn on notifications, and you'll be the first to know when a new video comes out. Thanks for watching, and we'll see you next time.